go. So we are to find the length of the sides of QRS. Okay, so RS is already given to us, it's 6. Okay, that means that since XZY is congruent to QRS, SR are the last two, right? So YZ right here has to be the same length. Okay, because we match up those letters, and that's what tells us that they're congruent from our congruent statement. So then we want to find QS. So QS are the first and last. That's the same as XZ. So these two are congruent to each other. Congruent also means equal. So when we have when we have a variable, we set them equal to each other to find the length. So we'll do 2b plus 1 equals 3b minus 2. So we go ahead and we solve this out. We would subtract 2b from both sides. We get 1 equals 3 minus 2 would be 1b, or just b, minus 2. And then we add the 2 over. So we get b equals 3. Is that the length of the side? 3? No, that's just b, right? So then we plug it in to find our length. So we do 2 times 3 plus 1. 2 times 3 is 6, plus 1 would give us 7. So that means over here it should be the same thing. We do 3 times 3 is 9, minus 2 would be 7. The 6 7s are killing me. I told the geometry team we had to change our numbers, and they didn't know what I was talking about. Anyways, so this one, we have 6c minus 2, and then we set that equal to the other side, which is 3c plus 4. I ran out of room a little bit. So we have to get this 3c to the other side, so we would subtract 3c from both sides. We get 6 minus 3 is 3c minus 2 equals 4. And we have a two-step equation. So we add our 2 over. We get 3c equals 6. And then divide by 3. And we get c equals 2. Is that our length? Nope, that's just c. So we plug it in. 3 times 2 plus 4. 3 times 2 is 6, plus 4 would be 10. So this side, 6 times 2 is 12, minus 2 would be 10. Alright. Any questions on the bell work? Awesome. So we have what's called the SSS postulate. Okay? This postulate says that 3 sides of one triangle are congruent to the 3 sides of the other triangle if and only if the 2 triangles are congruent. So, an example of this, we have MN is congruent to QR. There should be an R. It got cut off. Okay, and then it tells me that NP is congruent to RS. And then lastly, PM and SQ are congruent. So since we know that all three sides are congruent, we can say that the triangles are congruent. And remember, the order of the first one doesn't matter as long as you match it up with the correct order on the second one. So we are going to do proofs with these. So our proof skeleton, okay, this is just our outline. So you write your given on the first line just like normal, okay, and then the statement you're trying to prove on the last line, okay. That we already know from before. Then we have to find the sides that are congruent. We have to have all three sides that are congruent. Each pair line gets a statement and a reason. Then, once you have the three congruent sides, you conclude the triangles are congruent by SSS, because it's side, side, side. So, looking over here, we're going to label our sides with S's, okay? It's really important. Like right now, we just have S's, but soon we're going to have sides and angles. So we have to know which are which. So we're going to label them with S's, the ones that are congruent to each other. So on this side, we have this side is congruent to this one on the other side, triangle. So we have one S for both of those. Okay. Then we have this second side here is congruent to this second side here. So that also gets an S because that's a pair of congruent sides. Then that third one there, they both have 3 tick marks. So those sides are congruent to each other. So we get another S. So these ones, since there's 3 pairs that are congruent, we can say they're congruent by SSS. Okay, you're going to try these next two and see if they're congruent by SSS or not congruent. Those are your two options, either congruent by SSS or not congruent. So looking at these triangles for B, we have this side and this side both have 3 tick marks, right? Are there any other ones that are congruent on each side of the triangle? No. So this one doesn't have enough information. So I'm going to write not enough information to say that they're congruent or not. We can shorten that to NEI for not enough information. Okay, so we cannot say they're congruent because we don't have enough information that they're all the same sides. All right, on this one, we have this side has 1 tick mark, and then this side of the other triangle has 1 tick mark. So that's one pair. Is there another pair? Yeah, the ones with 2 tick marks, right? So we label those 2 with S's. Okay, and then in the middle, they share a side. So we can say that that side is the same as itself. Remember, that's the reflexive property. So that's our third S. So we spell it out, and it's SSS. So this one is congruent by SSS because we have 3 pairs of sides that are congruent on each triangle. I would write reflexive property on this one. We're going to use that a ton this unit. Okay. Alright, so let's get into some proofs for SSS. So the first thing, we're given the diagram. Okay, this diagram, 1 tells me that QP and SP are the same. Because QP and SP both have 2 tick marks, right? Is there anything else we're given in this diagram? The 1 tick mark and the 1 tick mark, right? So that is also given to us in the diagram. So QR and RS are congruent. QR is congruent to RS because it's given to us. Okay, they both have that 1 tick mark. Okay, then it's telling me that PR is congruent to PR. Why is that true? Yeah, the reflexive property. So you can put reflexive. I'm just going to put, I'll write the whole thing. It's the first time we use it. So reflexive property. Remember, you're the same as yourself. It's like a reflection. Okay, if you put reflection property, I'll probably count it. Good. Okay, so now we have, if we labeled these, I should have done that as I was going. With our S's, it spells out SSS with our 3 sides. SSS on both triangles. So we can say that they are congruent by SSS. Like I said, now it's easy because we just have sides, but sometimes we will have angles, which is why we want to get in the habit now of labeling our S's. Later, we'll have to label our angles as well. All right. We'll do one more together, and then we have a little other example to do. So, again, we're given this diagram. On this diagram, we're told that AB is congruent to what side on the other triangle? CD. So, AB is congruent to CD because that's given to us right here. I'm also going to label those with S's. Okay. We're also given that BC is congruent to what side? AD. Good. So BC is congruent to AD. That's also given to us because it has the 2 tick marks. And you also want to put S's with those because those are sides. Okay. Then it says that AC is congruent to AC. Why is AC congruent to AC? The reflexive property. Thank you. The notes are up there. Oh, that's fine. All right. So then that's our third S. So we can conclude that these 2 triangles are congruent by SSS. All right. So here's our last example. Okay, so we're given the AB. So if we counted from A to B, that is 1, 2, 3, 4, 5 units. Okay, it gives it to us right there as well. Okay. AC is 3 units. And then BC, they calculated it using the Pythagorean theorem, where we did 5 squared plus 3 squared, because it's a right triangle, right? And we get the square root of 34. So if we did this on the other side, we have FG is 5 units. FH is 3 units. And we have to find HG. So we do the same process. Our Pythagorean theorem, we do 5 squared. So A squared plus B squared equals C squared, right? Is our Pythagorean theorem. So my A and B, it doesn't matter as long as this is my C value. So we do 5 squared plus 3 squared equals C squared. 5 squared is 25. 3 squared is 9. 25 plus 9 is 34 equals C squared. And how do I get rid of a square? Square root. So we get C equals the square root of 34, or HG, the same thing. The square root of 34, which is the same as over here, right? So since all three of those measures are equal to each other on the other side, what are they congruent by? SSS. What we've been doing this whole time. Because we have one side, two sides, three sides. All congruent to each other. Okay. Sweet. Goodbye.